Uh, this it's wait a second. I need to create some new notebook. Okay. Okay. So speaking of dynamics, then I just want to tell you the first thing you should remember is that momentum is the product of mass and velocity. Now, momentum SI units are kg meters per second or Newton second. It's the same thing. Momentum is a vector quantity, which means that you will take care of the direction. Also, the formula for momentum is going to be P equals to mv, where P is the symbol of momentum, okay? Okay. So this will be your momentum, mass, and velocity, okay? Now, when you basically try to find the change in momentum, so you should remember that there got to be an initial momentum. And initial momentum is taken as mu, where obviously u would be the initial velocity, and then you got final momentum, which is equal to mv. Okay.
So can you just
Now,
show up?
yes, please. All right. So speaking of these two, the change in momentum in any question must be found out by doing mv minus mu. And I'm just going to write it here. V is the final velocity, u is the initial velocity, and m is the mass, as you guys know. All right, you should remember that. Now, this particular question, and these sort of questions will be there always. So you should always, look for, um, just remember that momentum is a vector quantity. That's the most important thing. And you should remember that you've got to find change in momentum, like they have said. Anyway, so right now, if you look at the first object, which is this one, you might see it's going down. And if it's going down, it means that if this direction you take it as positive, then you have to take this direction as negative. Or you can do, you can do the opposite as well. All right. So if you decide to go with these directions, okay, so then this will be positive and this will be negative, and that's very important to know because when you do, this, so the change in momentum, which is given by this triangle, it's called delta, this is change. The final momentum, oh, wait, why haven't they given us the mass? That's not fair. Wait a second. They haven't given us the mass because I didn't copy this. This is not fair. Wait a second. Let me just check the mass quickly. It is from 21 October, November. Okay, wait. Why? Why did I do this? It's 9702 21 October, November, and 20, right? QP. I'll tell you the mass. Just hold on a second. My mistake, my bad. Oh, it's winter 2021. Okay, so according to this, the mass. Oh, it's already. Okay, so the mass of this ball was. You can also add on your PDF because I cut one part. It was from kinetic energy. That's why 0.062 kilograms. So that's the mass. All right. Anyway, so we're gonna do MV minus MU. So mass is like um. So mass is 0.062. And now the final is like 1.7. So we're going to put negative 1.7. The reason I want to do it is because the direction we've taken up is negative, and then minus 0.062. And then this one, I took it positive. So it's going to be 3.8 only. Can you guys help me find this? By the way, I can do it now on my own as well. It's pretty easy now. This app is fine. So 0.062 multiplied by minus 1.7 is this one, minus 0.062 multiplied by 3.8. So I'm getting an answer of minus 0.341 Newton seconds. Now, I don't want to, because they only asked for the magnitude, so you can just simply write it as 0.34. You don't need to write any signs. Is that clear, everyone? Okay. So then I'm gonna go to the next one. This question is very similar. I'm gonna give you this as homework. You have to do this, please. So mark on your notebooks, and then we're gonna go to the next page. All right. So Zahan, Yaya, Wasam, Wajiha, you guys are clear about it?
Yes.
Yes, sir.
Yes.
Umar, Umar, Hamad, Suhail, Sultanat. Okay.
Yes.
Yes, sir.
All right, very good. Okay, so we're going to go to the next question and then we're going to start with impulse. So, impulse is defined as the force times, you can write times, it's all right, force times time for which this force is applied. So, what I mean by this is that impulse is basically the cause of change of momentum. And the reason is that if, let's suppose, you have two objects and the object was going at a speed u, all right, mass m. So, according to Newton law, the first law, it says that if you apply a force on it and that force for some amount of time, then this object is going to change its velocity. Okay. So this means what impulse is saying that the product of force and time results into change in momentum. Okay. Now, which means that this causes it to be mv minus mu because initially it was mu, the momentum, which was initial, and afterwards the momentum was mv. Now, this would mean that wait a second, please. I just need to do one thing. Okay. So this would mean that now if I could write it as force equals to change in momentum over time, or we could also write it as this one. So we get the definition of the force, and force definition is that it is the rate of change of momentum. This will be one mark now. So this is the correct answer. Now, what will be a wrong answer? The wrong answer, which most of the people write, is number one. People say force is a push or a pull. In A levels, it is not acceptable. In O levels, it was acceptable. The other definition they write is mass times acceleration. That is not the definition of force. Please do not write that. All right. So just I wanted to explain it to you. Only this one is correct. Anyway, so going forward, if you look at this formula, you realize that F is equal to, we can take M as common, and if we take M as common, then it will be V minus U over T. Do you guys know what is V minus U over T?
Acceleration.
Acceleration. So this is why uh, this basically states the Newton's second law, and Newton's second law is a derivative of how change in momentum per unit time is occurring. Okay, everybody understands this? Any question? Cool.
Sir, wait, can you explain that again? Wait, explain.
Yes. If you look at this, force is change in momentum. This is change in momentum, right? Can I take mass common, like out of it? It's the same mass, no?
Yeah.
So if I take it, then it's V minus U over T, and we know acceleration is V minus U over T, so we replaced it. Okay, sir?
All right.
All right. Now, going to this part. Now, if I just wanted to tell you something important. Like almost everything on Earth has some form of elasticity in it. Nothing is 100% rigid, which means that actually, even if you drop a golf ball, like a golf ball is dropping like this, so when it falls and it hits the ground, the golf ball gets squashed like this. If you do not believe me, you go and watch how golf ball is thrown on a hard surface, you'll realize that. And then it regains its shape and then it goes up, right? So within this time, when it is basically changing its shape, this takes some this takes some time. And that is the reason, if you want to draw a force versus time graph, obviously, so there's some characteristics on it. First of all, it is not sort of in certain situations, if it's like not 100% rigid, then the actual graph goes like this. So force increases to a maximum, and then this end of the graph shows that now it is pressing the ground. All right, if this was thrown on the ground or the wall, and the other half of this graph basically shows that this is basically leaving the ground. That's why the ground, or the ball, whatever it is, feels less, or the force on it is decreasing slowly. Is that clear, everyone?
Yeah.
Now, the thing is that what would be, like, if you look at this question, they say that which quantity of the time, right? Which quantity of the time, um, which quantity of for the time of contact cannot be found from the graph. First of all, if you look at this, you should understand that force is equal to change in momentum over time, and force into time is change in momentum. So if I multiply force into time, so you should realize that actually the area under this graph has to be change in momentum. You guys agree?
Yes.
Yes.
Okay, good. And then you should also be able to realize that actually you can find obviously the contact time between the ball and the club, because this is the time when it will be, deforming, sort of, right? So this is basically, we can find this, we can also find this. Now, going to the average force. So speaking of the average force, we should understand that obviously the force is changing, and we can, find force at different points, and then we can definitely find the average force as well, because, we can just add all the forces and divide by the number of points you've taken. So that is also correct. The reason we cannot find the maximum acceleration in this is because although we know what would be the maximum force that it will feel, but the real issue is that within this time, we cannot find any change in, a particular change of velocity and time. So for maximum acceleration, we must find change in velocity over change in time. This graph doesn't show that. So even if you draw some gradient, some try to do that, the issue is that we cannot determine the change in velocity from this, and that is why this should be something that we cannot do using a force times time graph. Is that clear? We can find average acceleration though. Is that clear, everyone? Any questions?
Sir, how can we find the average acceleration?
All right, so we can find it by using average force and then using FMA, like that.
Oh, okay.
All right, do you understand?
Yes, sir.
Which we simply cannot find change in velocity. So you should remember that. All right, change in velocity. You should also write this comment so you remember that this is the concept that I wanted to make sure you know. Okay, then. Speaking of this, then we are gonna go to the next slide, and I hope you guys have no questions here. If you do, please raise your hand, or you can speak. It's fine. So going to the next one. All right. Then we have another sort of graph in this, and that is the graph of momentum and time. Now, the reason I selected this question because I can then explain every part of this, and then I don't have to draw so many graphs. So it says an ice hockey puck slides a horizontal. Now it says frictionless ice ring surface. So there's no friction, which means that there are no forces which are going to reduce velocity. Okay. It collides inelastically and original path rebounds. Inelastic collision, most of you might have done now because I think you guys are doing this for the second time. Inelastic means that the kinetic energy before is not equal to kinetic energy after. In fact, that kinetic energy before is greater than the kinetic energy after. Is that clear? Or not equal? It could be like that as well. So this is inelastic collision, which means that before it might have higher velocity, afterwards it doesn't have that. And now it says it goes, hits the surface, and comes back. Okay. So two things. First of all, we should understand that momentum is a vector quantity, which means when the momentum like object was going in this direction, if we take that as positive, then when it has rebounded, we should take it as negative. All right, everybody agrees? Khatija, Squares, and Javeria.
Yeah.
Yes, sir.
Okay, now, so then one side has to be positive, like this one, and one side has to be negative, like these two. So definitely these two graphs are absolutely wrong. It can never happen like that in a rebound case and a momentum. Is that clear? Okay. Now, going to A and B and why I would pick A over B. Okay, so I'm going to write some reasons here. So you should also edit this. First reason is that it is a frictionless surface. Frictionless surface means that obviously there is no reduction of velocity whilst moving, which means when it was moving, which is this section, right? It has not hit the surface. It means there was no reduction of velocity at all. And that's why it is a straight line. It's a constant momentum, which means mu is not changing. In this one, however, if you see the mu is changing because the momentum is reducing, because obviously the velocity would be reducing. So it means this graph can be only possible if there was friction. Speed reduces. All right, so we should remember that. Then both of them for the rest of it is correct because when you hit something, so it causes it to change the direction. So in this section, which you see, there is a visible change in direction. And how do we know? Because in both the cases, it's the same. It's because that graph shifts to negative. So you should always look for that. And if you know that, then it would be obviously correct. So that's why A is the correct answer. If there was friction, then B would be the correct answer. Is that clear?
Yes.
Okay, Ali, Munim, Ryan, and Saltanat. Ahmed Aziz, Ayan. If you guys have any questions, do let me know.
No, sir.
Okay, good. Then going towards Newton's second law. Now, Newton's second law is basically
Can
written
you
as...
go up for a little bit?
Yes, and why not? You can copy this down.
Okay, then. Thank you.
Okay. Now, Newton's second law is basically the definition of resultant force. All right, so this is the crux of it. And Newton's second law is written as resultant force is the rate of change of momentum. Please do not write mass into acceleration. That would be wrong. The only condition for this is that you should remember that resultant force and acceleration are always in the same direction. So if they ask you this, you should be able to remember this. This is very, very important. All right. And that is the reason F is equal to ma. So whatever the direction of force is, that is the same direction of the acceleration. Okay. Please write this down as well. Okay. All right. So then one of the things that they will ask you, and they have asked previously as well, and that is Newton's first law is also called law of inertia. And I'm going to tell you what inertia is in a bit. But right now, I just want to tell you one fact here, fact. And this fact question is there in the topical papers as well. You can check. The fact is that Newton's second law came first and first law came second. The reason Newton basically wrote first law as the first law, although he basically did it like after the second one, because the first law is the explanation of the second law. And that is the reason mostly we make sure that we teach them together. Anyway, so the law is that an object will continue to move in a straight line at constant velocity. All right, so this is the first part. The second part is writing or stay at rest. The third part in this is unless an external force act, which means if a resultant force act, obviously it is going to go accelerated, maybe change the direction, change the shape, or change the velocity. So what you guys need to remember is that a force is capable of, number one, changing velocity or speed, then changing direction, and third, changing shape. So you should remember that always. Okay. Now the next thing that I wanted to basically tell you about and we wanted to discuss is what exactly do we mean by inertia? So inertia is basically the resistance of a mass to the change in motion. All right, so this is the simplest definition that I can give you. And the definition of inertia will not be there. So do not have to worry about that. You just need to explain, you need to understand that obviously if you're sitting on, a high speed train, okay, so this is your chair. And if the train basically something like this, right? So in an event when the train basically causes acceleration forward, so your body resists this change because acceleration is change in velocity, right? So the object basically is pulled backwards. So your body is going to go back. Have you felt it like that? Also, if you're basically sitting on the same chair, but this time the train is trying to stop, so acceleration is the opposite direction. So your body is going to go forward, and the reason is that it is causing this acceleration, like it is resisting the change to this acceleration. It doesn't want to stop, it wants to continue going in the forward direction. Everybody understands this?
Yeah.
Yes.
And that is the reason we have airbags and seat belts, so that we could minimize the effect of inertia, right? In case of a sudden deceleration or something like that. So you should write that down, please. Okay. So about inertia, he's not going to ask you directly, but with reference to first law, and you will see ahead that he's going to ask you certain questions, so you should be aware of that. Okay. Uh-oh. My tea has gone cold. Hmm. Okay, going to the next part then. So then in this chapter, the first set of questions will be of inclined planes. Now, inclined plane questions are almost 40% of all the questions that come in forces. So you should be very, very particular about them. So first of all, let's look at what is an inclined plane. Inclined plane means that the surface is at some degree theta from the horizontal level, all right? Which means whether, no matter how many degrees it is, you should always remember that the weight will act down, right? So W is the weight, and it always acts vertically down. So which means that obviously then weight will have two components. First component of the weight acts downwards to the slope and parallel to the slope. And the other one is perpendicular to the slope. Perpendicular means it's 90 degrees like that. So now we are going to look at the component of weight. So components of weight are number one, down the slope. And this component will always be W sine of theta. The reason is that this angle you see here, is basically the same angle as this one. The other thing is that the other component, which is perpendicular to the slope, will always be W cosine of theta because next to the angle. So you can always write it as well. W cosine and W sine. All right. So this is a fact and it will always be like this. If you want me to explain to you why theta is this theta and that theta, the blue one and the red one, are the same angles, I can do that, but that will just take up some time. That's all. You guys want me to explain that? Okay, very good. You guys are smart. Now, so what I'm saying is, first step, you're gonna make weight vertically down. The next step, you're gonna make the component of weight down the slope. The third step, you're gonna make the component perpendicular to slope and put the angle here in the fourth step. Will you guys be able to do this?
Yes.
Rest of the things can be managed pretty easily. Like there could be other forces on the diagram as well. And if they give you other forces, you can always, put them equal to certain forces. Like for example, you can basically target all the forces which are in this direction separately and all the forces in this direction separately. And obviously, it might be accelerating, it might be in equilibrium, we don't know that. But this is the real thing that you guys need to do. If you just focus on this, it means that if you've done this right, you will always get this sort of question correct. So let's try to solve certain questions and try to understand how it's done, right? So speaking of the slope, I think, have you guys done it? Should I go forward?
Yes, sir.
Okay. So going to the first question. Now, in this question, it says a 2 kg of 2
Check the
kg.
go for a second.
Yes, please.
Okay, thank you.
Okay. So in this question, it says a 2 kg a mass is released from rest. Okay. and it travels 7 meters down the slope and falls vertical distance 3, the ball experiences a frictional force of 5, right? So right now, what I'm going to do is I'm going to take up that information and I'm going to try to solve it down. First of all, the first step that I should always keep I should always keep in mind is that this I have to make a vector down as weight. All right, is that clear, everyone? Can you guys do it? Then the next thing I'm going to do is I'm going to make one vector down the slope of the weight and one vector perpendicular to the slope, right? The real issue in this question is that I do not have this angle theta. So how would I find this angle theta then? It is pretty simple. But just looking at the diagram, we should understand that this height from this point to this point, this is 3, and the this slope is 7, which means that actually this is a triangle like this, right? This is 3, this is 7, this is theta. Can you find this theta, please? Which formula should we use? Sine, cosine,
Fine.
tan, sine. So we'll use sine theta equals to perpendicular over base, right? So theta will be equal to sine of inverse 3 by 7. Can you please help me find this? Your calculator should be in degree mode, not radian mode. So you always, whenever you start doing a physics exam, you should always check your calculators, because usually if you come after math exam, you will get wrong values then. Okay, so I'm getting it as 25.4 degrees. All right, please check if that is the angle. Okay. The thing is that now I already know that this will be W sine theta. This will be W cosine theta. And because it is going down, the friction force will act above, because friction opposes motion, and that is 5 newtons, right? So now from this point onwards, it says I need to find the speed of the distance fallen. The issue is that to do that, I need to use SUVAT. The displacement I have is 7.0, initial velocity is 0 because it started from rest. The final velocity is what I need to find. I do not have the acceleration. Please do not use 9.81 here because it is not falling vertical. All right, let me write it down so you guys remember later as well. Do not use 9.81 here because it is not falling down vertically. Okay, so then what you're going to do is you do not have time. So the thing is, we need to find the acceleration. To find the acceleration, I'm just going to look at this line. And to do this, I know that the resultant force F would be equal to W sine of theta minus 5.0 newtons. You guys agree?
Sir,
Yeah.
how did you find?
5 was the opposing force, right? Was the friction. If it's going down, the
Right.
friction up, right? Now, F will be W can be defined as weight. Weight is mass times acceleration due to gravity. So this is weight. Sine of 25.4 minus 5. Can you please help me find this? So this would be 3. Please do check the answers as well. Don't be a lazy ass. Check your answer if that is the correct one. All right, check my answers as well. Okay, so I got the resultant force, and to find the acceleration, I can use F equals to ma now. I have the resultant force, I have the mass, and I want to find the acceleration. And that would be 1.71 meters per second squared. And that should be my acceleration, right? So now the best equation to use would be 2as equals to v squared minus u squared, because we do not have time and we have to add this. So 2 times 1.71, displacement is 7. Final velocity is what we need. Initial velocity is 0. So can you guys find v, please? And let me know the answer.
A, sir.
4.9 meter per second.
Yeah, so it would be 4.9 meters per second. That would be it. All right. Anyone in this class who could not understand this, who still have certain issues, please let me know. Ahmad, everything is clear? Munim, Masam.
Yes, sir.
Okay, cool. All right. You can copy this down. Zahan, Yaya, Wajiha. Okay. Now, so speaking of this, then let's go to the next page and see if I did post some of the questions. Now, these sort of questions are pretty easy. I want you to do this one, this as homework, but I'm going to help you with this one. This is pretty easy. Okay. Now, it says a car of mass m, it travels at constant speed up a slope at angle theta, and air resistance friction provided by this. So there's a resistive force as well. Now, what you need to do is, anybody can tell me what is the first step we should do?
Make the components of weight.
No, you make the weight first, which is perpendicular down or onwards. Then make the components. Where would be the components? The first one, up the slope or down the slope?
Up the
No, always down the slope. Is it clear? Wajiha? Sultanat? Juvaria?
Yes, sir.
Then the next component is
Sir, wait, can you explain again? What did you say?
Perpendicular to the
What-
slope.
yeah, perpendicular. I said in response to somebody's response, I said, what is the next step? She said, it would be a component up the slope. But I said, no, that's not possible because component should be down the slope. Do you understand? Weights component, always. All right. Then you need to make a perpendicular component like this, and this would be angle theta. So this will be W cosine of theta, and this will be W sine of theta. Everybody agrees?
Yes, sir. W sine theta, does it represent positive value or a negative value? The first.
We haven't assigned any signs yet. Right.
All right.
Okay, now, so once you've done it, almost half the question is already done. Because now what he is asking is that what force is needed to propel the car at constant speed. So it means the car is being propelled at a force, and this force needs to be equal to all the forces which is trying to pull it down. Do you guys understand this? Right? Which means that the forward force should be now equal to the resistive force F plus W sine theta, because both the resistive force and the W sine theta are trying to pull it down, where we need to provide a force which should take it upwards, and it should be equal because it should go at constant speed. You guys understand this?
Yes, sir.
Yes, sir.
So then the answer will be F plus W is equal to mass times acceleration due to gravity and sine theta. And the answer is D. Is it clear?
Yes.
Good. The next question is of a similar nature. I just want to tell you W work done, because you haven't done work done with me. So I just want to tell you is force times displacement, and force and displacement must be parallel. So you need to keep that in mind while solving this question. So you can write this comment as well. And when you're doing the homework, you can do that. Okay. Okay. Now, going to the next one. Okay. So this question is another question which is a bit tricky, but I want you guys to test your limits here and try to do it as homework. If you do not get it by tomorrow, then obviously you can ask me in the class and I'll explain it. Okay. And same goes for this one. Homework, please. And I want to do this one basically. All right. And let me see if I have given the next thing. I've given a lot of questions because there are a lot of questions already on this, right? Okay, yeah. So this one as homework as well. And this one is a pretty easy question as homework. And this one also as homework. Okay. But then I'm going to solve this one only. So Newton's first law. Anybody can tell me what is the first law? Go on, please. An object.
An object will continue to move in a straight line at a constant velocity or stay at rest unless an external force acts.
Yes. Continue to move in a straight line at constant velocity. Very good. Or stay at rest unless an external force acts. Okay. Now, it says the angle to the slope that makes with the horizontal is 12 degrees. The frictional force acting on the log is this one. Okay. Then it says the log travels with constant velocity. Okay. And it is going, I think it is being pulled up, right? So if it is being pulled up, so the force of tension should be up, and the friction force, because it's going up like this, so friction force has to be backwards. You guys agree? So let's write friction as 650 newtons. Now, it says with reference to motion log, discuss whether the log is in equilibrium. You guys think it is? Oh, equilibrium, I'll just tell you this myself. Equilibrium means that basically there are two things in equilibrium. One, anything in equilibrium must have resultant force equals to 0, and anything in equilibrium must also have resultant moment equals to 0. So there shouldn't be no net force and no net turning effect, right? So this, if you write these 2 points, obviously you get the mark. But this we will do again in equilibrium forces, so that would be good. But I just want to focus right now on this question. So it says calculate the tension on the slope. So now you guys need to help me. What do we have to do first when we look at the slope? Anyone? What is the first step that should come in your mind?
We have to draw all the components.
No,
Draw
we have
weight.
to, you have to draw weight. Okay, we got to draw weight. Once you've drawn the weight, what is the next thing we should do?
Make the components.
Which component first?
Down the slope.
Down the slope. Okay, so one down, one. The other component is
Perpendicular to the slope.
perpendicular to the slope. And this angle has to be 12 degrees, right? So this one is going to be W cosine theta. This is going to be W sine of theta. Now it says calculate the tension. So if it is going at constant velocity, can we say, what equation should we write? Can somebody please help me write the equation? You just need to look at everything on this line where the tension is. Everything on this
W
line.
sine theta plus 650 is equal to tension T.
W sine theta plus 650, which is the friction, equals to the tension T. Is that clear, everyone? Because it is in equilibrium, right? Now, the weight, the mass is 450 kg. So 450 times 9.81 times sine of 12 plus 650 equals to tension. And that's when you get the question solved and free 3 marks. Okay.
Sir,
So,
wait.
yeah.
What's the W here represents the weight down below?
W sine theta, yes.
No, just the W. Does it mean it's the weight acting down?
What are you talking about? I didn't understand the question.
The W, yeah. Does it show acceleration due to gravity?
Yes, obviously. So W is always equal to mass times acceleration due to gravity. So that's why you need to put 9.81 to find it. Okay.
All right.
All right. Now, if I write my answer as 1568 newtons, do you think I have done the right thing?
1600 meters, maybe.
Okay. So because the data given is two significant figures. So either I have to write, this is absolutely wrong. Either my answer should be 1600 or I could write 1570. Do you guys understand this? Also, because a lot of teachers tell you that, and a lot of people I've seen write both the answers. So do not write both. Pick one only. Okay, so answer space is only for one answer, not both. Everybody understands this?
Yes.
Okay. So whenever you've done the question, always check for the significant figures. It is very important. Every question has 1 mark for significant figures. The total paper is of 60 marks, and there are 6 to 7 questions, sometimes even 8. So imagine losing 1 mark in each question and getting like 7 wrong out of, doing everything right. That would not be cool. Okay. All right.